I'll try to bring a rectangle into perspective and vice versa, so you can understand what is a vanishing point first. Next, what is the measurement or the zero line. We will get to it in a second. How objects converge into vanishing point or points depending what perspective we are using. How we are using horizon. How we create a perspective distortion and how we recreate it. And finally, in the last part, the third part of this exercise, at the end of this video, I'll try to show the practical part, how we will use all this information to recreate the objects that we will need to model from images. So one more time from the start. I've created an object. This will be any object that we will have to model. Next, I've created a camera. This will be our eyes, or the person that it is watching, or us. After that, we created the horizon line, and we draw from our eyes two lines. This will be our field of view. In other words, we can say that this is the way how our eyes are looking at the world or at the objects. After that, we created a segment. It can be any standing object. For example, it can be even a person. Now said that our eyes perceive the object smaller when we increase the distance between our eyes and the object or the person, whatever. That's where the perspective distortion interferes. And we connected the object or the segment with the vanishing point, as we said. The point where our eyes are not capable to see anymore. It turns all into a point. Below this segment, we draw a line, a horizontal line. This will be our tape or our measurement. This is also like a border. In the first part, in the upper part, we got our 3D or our perspective, including the distortion. And in the down part, the part below this zero line. By the way, two reasons why we are using this zero line. First, the objects that we will see will be on the floor. This will be like the zero or floor level. The second reason, or the second part, is that the part below this zero line, down the zero line, will be the part where we will project our objects, so we can get the distance from the distortion in a proportion 1:1, or in the right proportion. I know it may sound a bit confusing. Be patient, we will get to the practical part and you will soon get it. These are the perspective rules. So if on my segment, being in a 3D space, it's applied the perspective distortion, for me to reconstruct it correctly, I'll have to bring it to a correct proportion or correct dimension using some techniques. This segment is actually the edge of any object you will see on an image with a 3D model. Next, I'll have to simulate a compass, and we said that the space below this zero line or this measurement line, it's the projection or 2D space, but my segment is in 3D space. So to get rid of that perspective distortion from 3D space, I'll have to bring it from 3D to 2D. That's why we will use the compass and we will get the 0 point, or the point that connects the 3D and 2D spaces, and I'll rotate it until we get it to our horizon. There we will get another second vanishing point. Same thing I'll have to do with the segment itself. I'll have to rotate its front edge. Well, in this case it's only a segment, and its front edge is the same edge that lies on the zero line that connects this 3D and 2D space. In this case we can say that we are bringing its height on the projection or the 2D space, and doing that we are getting rid of the distortion, the perspective distortion. We are getting the right dimension of this segment. After that, we can measure it. If you remember, our zero line was the measurement tool or our measure line. But you can say, wait a minute, what this measure is linked to? Well, this measure is only linked to the first part of our 1:1, to the proportion. And you will be right. Second, we need a scale, so we can get our measure to a standard. What we did here was only the first part, the proportion part. Yes, we got rid of the perspective distortion and we brought our segment to be in the real dimension. It's real dimension in the scale of this drawing, but in this case we draw just a random segment. That's why when you use 3D models that we will have on our images, they will be only in proportion. You will not know only by image its real dimension. We will need the plans of that object so we can see the scale, the real scale or the real dimensions of that object. Only then you will be able to link the proportion and scale together to bring the object to be one-to-one.